Here in question 7, we're given a situation where we've got some clay on a turntable and we're given some data for that. So let's start writing this data down. First of all, we're told that we have a mass, let's call that M, of 300 grams, which is the same as 0.3 kilograms. It's placed on the turntable and the radius between the clay and the center is 12 centimeters, or we can just say that the radius equals 0.12 meters in SI base units. We're also told that the lump of clay takes 1.6 seconds to complete one revolution, which indicates that we have a period T of 1.6 seconds. In part A, part 1, we are asked to calculate the rotational speed of the clay. Well, we do have an equation that says the speed V is equal to 2 pi r divided by T, the circumference divided by the period. And then we can simply plug in our values, as we have the radius and we also have the period. So we can say that's then 2 pi times by 0.12 all divided by 1.6. And if you did that on a calculator, it would give you possibly a value in terms of pi to be 3 pi over 20, and then the units of speed, meters per second. Alternatively, you could have a decimal answer of 0.471, and again meters per second. That's been quoted to 3 significant figures. Part 2 then. Calculate the frictional force between the clay and the turntable. Well, the frictional force of the clay between the turntable would be providing the centripetal force acting inwards. And this is because the table is flat, gravity isn't coming into play, it's just going around. And so we know an equation for centripetal force to be F equals, well, thinking about this, we have a velocity, we have a radius and a mass. We could then say that the centripetal force, which is equal to the frictional force, is mv squared over r. There's also the equation that centripetal force F equals omega squared times r. However, to get omega, the angular velocity, we'd have to go down another path anyway, so it's not really worth our time there. So simply inputting our values for this, we'll have the mass to be 0.3 times the speed squared, speed we just worked out. Let's use the answer in terms of pi to not lose any accuracy, or that would be squared, and then divided by the radius, 0.12. If you did that on a calculator, you'd get an answer then of 0.555 units of force newtons, and that has been quoted to 3 significant figures. Part B. Maximum magnitude of the frictional force F between the clay and the turntable is 70% the weight of the clay. Well, without reading on, we've effectively got then, we can build an equation from this. F, the frictional force, F max, let's say, is then equal to 70% the weight of the clay. Well, 70% we can then say is 0.7 times the weight of the clay times W. And the weight would be mg, so we can take this a step further to say that the frictional force F maximum is equal to 0.7 mg. We're then told that the speed of rotation of the clay is slowly increased, and we're asked to determine the speed of the clay when it just starts to slip off the turntable. Well, if we increase the speed of rotation of the clay, we're increasing the centripetal force, and we already know that the centripetal force is provided by the friction. So we've got a value then that the centripetal force increases and increases, and then it will effectively reached this value, we can say that the centripetal force, so let's call it F subscript C, equals F max. And we can use the centripetal force equation. Let's use mv squared divided by r. Using this version as we're wanting to determine the speed, and that is equal to the equation that we've just showed, 0.7 mg. And all we need to do now, as we know the radius, we know g, we can just rearrange to make speed the subject, while mass cancels on both sides, times by r, take the square root, we'd have v equaling 0.7 gr, and that's all square rooted. Simply inputting the values then like so, we'd have 0.7 times g is 9.81, and then the radius 0.12, and all of that would be square rooted. And if you did that on a calculator, you'd get a value of 0.908 units of speed, meters per second, and that's quoted to 3 significant figures.